Welcome. This is the first video that I'll be screencasting to help you resolve any confusion you might have about short-run graphical situations in perfect competition. So the first possible situation we're going to look at is what does a long-run equilibrium look like, and we'll help you kind of build that graph. So to start with, I would draw two sets of axes, and I would label those axes, and then I would draw in my basic cost curves, and we know marginal cost curve is the one you draw first, and it's shaped like a swoosh. And then you start from that middle point and you come away and up in both directions, and that gives you your average total cost curve. And then you go to a point lower down on marginal cost, and you come away and up steeper to the right and away and up a little less steep to the left than you did before, and that gives you your AVC curve. And you can note that each of these has absolutely a unique minimum point that's on marginal cost, and that they get closer together as we move further to the right. The distance between them, once again, is average fixed cost, and we know that decreases as quantity increases. Now, the trick to drawing long-run equilibrium correctly is to not do the market or industry graph until after you've finished the firm graph. Obviously, the intersection of supply and demand over on the right-hand side will give us a price, and the firm is a price taker, and that'll establish the height of Mr. DARP for our price taker firm. But it's kind of savvy to build it in the opposite direction, because this way you put in your Mr. DARP tangent to the bottom of ATC, just touching it once, and then you establish a demand curve and a supply curve. And here it's nice to know that if I want to really label accurately, I want this to be supply equals the summation of all the firm's marginal cost curves. And that's something we can circle back around to a little bit. But I want to make sure now that that demand and supply curve intersect at exactly that same height as I put that Mr. DARP tangent to the bottom of ATC, which means that MC equals MR happens for us at exactly the quantity where ATC is at its minimum. And then we can establish our industry quantity, and we can think about the firm and how many units it'll make, and it'll follow that MC equals MR rule, and we'll end up with a picture that looks a lot like this. I'm going to hop to a screen where I already did that, and then scroll down a little bit and go ahead and think about some areas. So that's your long-run equilibrium picture. And we'll prove that it's long-run equilibrium because we can prove that by determining that there is no profit or loss associated with this. So the first thing I want to do is be able to identify where the firm's total revenue box is. So I've got this box for total revenue. It's right here, and I've labeled it TR. It's going to be shaded orange. And total revenue, just to remind us, is quantity times price. And it's also quantity times average revenue, because average revenue and price are the same thing. The quantity in particular I'm thinking about is Q star. Remember, I established the quantity the firm is making first, and then I'm going to think about my areas. And if I don't follow the MC equals MR rule, I'm going to end up with areas that are all the wrong width. So here you can see that's total revenue. It fits right there. Maybe it's a little smaller than that, but it looks like it fits in that space, so that's nice. And if we wanted to look at the firm's total cost, well, there it is as well. It's right in that same space. This is total revenue because it's average revenue times the quantity I make, or it's price times the quantity I make. This box is total cost, but for kind of a different reason. This box is total cost because it's ATC of the quantity I make. So here's ATC. It's a function. It's like an f of x you'd have in math. Well, now I know a particular x value. Q star might be 24 units. And when I make 24 units, this is the ATC I experience. So it's ATC times the quantity. And another way to think about total cost, of course, you can see in that green box, is that it's fixed cost plus variable cost. Well, what's variable cost? It's right there. Let me find AVC of Q star and multiply it by Q star. That should give me that box there. And if I've done things right, this box down here will be labeled fixed cost, and that's the rest of their total cost. Remember, average fixed cost is that distance right there if you make Q star units. And so ATC minus AVC will be AFC times Q star is total fixed cost, or just fixed cost. So you can see here, total cost equals variable cost times fixed cost. Oops. But if we do this, then it'll be on top. And we can see that it's exactly the same size. Because total revenue and total cost are the same size, there would be no profit and no loss. So that's a nice way to think about the long-run equilibrium picture. Let's do another one real quick here. If we want to do a situation where a firm's earning positive economic profit, we have our axes and we label them, and we establish our cost curves in the same way we would have before, and we drag some stuff around into a position where we have Mr. DARP somewhere up in here, you know, and then we want to make sure, though, that Mr. DARP is crossing ATC twice. We want some space in there where ATC is underneath Mr. DARP. That's the range of quantities over which the firm will be able to make a profit. And then we can arrange a D and an S. And you notice my strategy for graphing every time is that I'm going to do the firm graph, and then I'm going to come back and reverse engineer the market graph. Even though in real life the things happen in the market graph and then they have consequences for the firm. It's easier strategically to draw the graph if I'm able to come over and figure out where supply and demand ought to be after I've established where I want my Mr. DARP. Of course, if they follow the MC equals MR rule, then they would be operating right there. And the industry quantity, I guess it needs to be a little bit taller than that to capture, but there's capital Q star. So that's what it looks like when a firm's making profit. And here's one I did earlier, but made out these areas as well. So we can see for much the same reasons it was just a moment ago, that this firm's total revenue box is right there. That's quantity times price, or it's quantity times average revenue. So we'll go ahead and just set that there. That's nice. And then let's think about what the firm's total cost is. Of course, I could break it up as fixed cost and variable cost, but I'm going to go ahead and set that aside for a moment. I'm just going to put their total cost. It's going to be right here. Now, how do I figure that out one more time? What's ATC of Q star? That's this point where the cursor is right here. And then I need to multiply that vertical distance. That's the firm's average total cost. I need to multiply that by the quantity of units the firm produces. Boom, right there. So if we go ahead and layer total revenue on top first, and then total cost, we can see that total revenue is bigger than total cost. So that proves that we're making a profit. And in fact, the area of economic profit that we practiced shading in class is that part of total revenue that's not total cost. So there it is, boom, right there. Remember, in this case, total cost represents implicit plus explicit costs. So this is just economic or pure profit that's sitting there. Okay. Let's get those out of the way. And then we can move on and consider the loss case. So, all right. So if a firm's minimizing loss, what does that mean? That means that there is no quantity they can produce that will lead them to making a profit. In fact, every quantity they make leads them to take a loss, and they're trying to find the quantity that makes their loss the smallest. They're still profit maximizing. It's just that the maximum value of their profit function is a negative value. So how would we do that? We're going to go in here and we're going to put Mr. DARP down here. It needs to cross AVC twice, but it needs to never touch ATC. So there we are. And then we can put a demand curve and a supply curve in a position where they cross at that same height, P star over here. And that gives us a market or industry quantity. We think about what quantity the firm would want to make, and we compare MR, that's this line for reasons of it being MR, with this swoosh, okay? And somebody asked a good question the other day, what if it crosses the swoosh twice? Well, I definitely want to take advantage of these units in here. These are the cheapest ones to make. I'm never going to make a profit if I don't take advantage of those. So we want to find that place right here where we cross the upsloping portion of marginal cost, and that's the quantity the firm will want to make. Here's one I did a little while ago, and feels like doing a cooking show, how I could just pull a finished pie right out of the oven or something. But I've got these boxes here, and these boxes hopefully will help us tell the very same story. It just won't be as pleasant of a story for the firm. What do we have here? I have total cost. Boom. How did I find that? I found ATC of Q star. Probably in this case, what you need to do is make your Q star dotted line a little bit taller, so it extends up there, and I'm looking for that spot right there, ATC of Q star. Boom. So I take that times quantity, and that gives me total cost. Now I can find total revenue. That's average revenue or price, whichever you prefer, times the quantity you make. You can see there's total cost bigger than total revenue, that green box bigger than the orange one. And so the part of total cost that is not offset by revenue, in other words, the amount of which total cost is bigger than total revenue, is that economic loss right there. One thing that I'd like to make sure that you draw attention to as I flip back through these pictures is to remember that when we have our economic loss box, Mr. DARP is the bottom of it, and ATC of Q star is the upper right corner. Notice that minimum ATC, or ATC crossing marginal cost, that point is not part of that box. It's none of the corners. Think about the profit box. We showed it right, oops, where's that profit box? That profit box will be right here. And if you do that correctly, ATC of Q star, sorry we can't see Q star here, there it is. Okay, here's Q star. ATC of Q star is that spot right there. And notice that that minimum ATC point is outside of the profit box and it's not part of the profit box. The firm isn't experiencing minimum ATC. They're experiencing ATC up over there. If we come back to the long run equilibrium picture, there's an additional bit of fact that's sort of useful to think about here. We talked earlier on in this unit about allocative and productive efficiency. We kind of defined those a little bit earlier on in the trimester, and we'll think about what happens with this firm. The firm's choosing to produce Q star units of output because that's the quantity that maximizes their profit, the quantity at which MC equals MR. You can see right here, that's Q star units of output. Any other quantity they would produce, they would take a loss, but at this quantity, they're able to break even. In this example, you can see that's why economic profit is 0. We went through the TR equals TC, and your eyes will become glued to the idea that when Mr. DARP's tangent to the bottom of ATC, then there you go, you know that's a break-even situation in long-run equilibrium. In terms of evaluating the outcome, we like to think about, is this situation economically efficient? And that's where you're looking at this section here. This situation is productively efficient because when they make Q star units of output, the firm is minimizing its average total cost function. It's making each unit as cheaply as it can be made. And that's the standard for productive efficiency, is that the quantity you're making leads to the minimum possible value of average total cost. The second thing is we wonder about allocative efficiency. You remember we learned about that when it related to deadweight loss. In this case, the result is allocatively efficient because the price consumers pay, P or P star, is equal to the marginal cost of producing that last unit. The marginal cost of that Q star unit is equal to price. And let's just come up here and think about that a little bit. The marginal cost of the Q star unit would be whatever value the MC function has when I plug in Q star for Q. And so that's this value here, and it equals price. In fact, we'll find out that for a perfectly competitive firm, they're going to be allocatively efficient anytime they maximize their profit. They're only going to be productively efficient when we are in long-run equilibrium. So hopefully that helps you with the basic situation of the loss case, the profit case, and the long-run equilibrium case. And you should watch 1 or 2 more videos from me about the shutdown rule and about what happens when we allow things to roll into the long run.